This is video number 50 on a series on foundations of arithmetic, algebra, and graphing. My name is Bill Kinney. It's part 9 of a sub-series on algebra, formulas, functions, and graphing with an emphasis on spreadsheet usage. It's the third video where I'm showing you stuff about spreadsheets. Here's the spreadsheet we've looked at in the first couple videos. Going to in the spreadsheet, which is labeled, I haven't named it yet, it's called Workbook 4 up here, you can see. I will name it at some point. I've got, if you look down here, I've got a couple different sheets within the overall spreadsheet, in a sense like a couple different pieces of paper. Sheet 1 is what we're on. If I click on this one, we come to sheet 2. I will go to sheet 2 here in a second. You can also insert a sheet by clicking here where it says insert sheet, and that'll give you a new sheet. But I do have something on sheet 2, so I'm going to go back to sheet 2 here, click on that. Something different than what's on sheet 1. You have different things in different sheets within the overall spreadsheet. And here's our problem in sheet 2. Find a formula for a function that will give you the temperature in Fahrenheit if you know the temperature reading in Celsius. Get a table of values for the function and graph it as well. Alright, there's the basic problem. We need extra information. If you only were given this much information, it's really not quite enough. You need to know some things. For example, you need to recall that at least at standard atmospheric pressure, water freezes at 0 degrees Celsius, which is the same as 32 degrees Fahrenheit, and that also at standard atmospheric pressure, water boils at 100 degrees Celsius, which is the same as 212 degrees Fahrenheit. I'm going to use C to represent the Celsius temperature, capital C, and a capital F to represent the Fahrenheit temperature, and I want a function that will give me F if I know C. Think about the question up there. You want to give you the temperature in Fahrenheit if you know the temperature in Celsius. I want to be get F if I know C, and I probably better call this function something other than F, like a G. So F will equal G of C. What else do I need to know? It's treating that C like a copyright symbol there. Well, I'll just pretend that the G of C is there, but then I'll erase it. What else I need to know is I need to know that this is going to be a linear function, that its formula will be of the form y equals mx plus b, or in these variables f equals m times c plus b, where m is the slope and b is the y-intercept, and I need to find what those numbers are. Hopefully you recall from back about 4 videos or so ago that the slope of a line is rise over run, which is also the change in y over the change in x. Delta y over delta x was the symbolism and the way you said it. In this case, it's delta f over delta c. Maybe I even want to type it that way. Delta f over delta c. I'm not typing a formula here at the moment. Maybe I'll put this over here. That's going to be the slope. Change in the Fahrenheit temperature divided by change in the Celsius temperature. As you imagine the actual temperature changing from freezing temperature to boiling temperature, how does F change? It increases from 32 to 212. So the change in F is 212 minus 32. Notice how I'm typing this. I've noticed the equal sign, notice the parentheses, divided by the change in C as you go from freezing to boiling. C goes from 0 to 100, so the change in C is 100 minus 0. Notice you need the equal sign if you want to get it to do math. Notice again the parentheses, order of operations. I need the parentheses so that the subtractions are done before the division. If I didn't have those, the division would be done first. So I need that. There we go. The slope evidently is 1.8, which is the same as 9/5 if you wrote it as a fraction. What's I shouldn't call this a y-intercept. I should call it a capital F-intercept. C is going to be in the horizontal axis back and forth. F is going to be in the vertical axis going up and down. What's the F-intercept? That's probably best just to think about here. Look at the formula there. When C is 0, freezing, you would get m times 0 plus b, which is 0 plus b, which is just b, which excuse me, has to be 32, because we know for Fahrenheit, freezing is 32. So the intercept must be 32. I actually don't need to type an equals in there. If I just type it as a number without anything extra, it will store it as a number. So now I can do operations on it. Let's make a table of values now. Just to show you that I can, instead of increasing C by 1 every time, I'm going to increase it by 2 every time. Notice how I'm typing this. In cell B17, I typed in equals B16 plus 2. So C is going to go up by 2 every time. I could also make it go up by 0.5 every time if I wanted to. I'm going to pick 2. Click and drag that formula downward. Let's go all the way to 100 here. Too far, but I'll just go ahead and keep those. Alright, now what I'm about to show you is a little bit tricky. Make sure you're really paying attention. I want to type in a formula into Excel that will give me the corresponding Fahrenheit values for the corresponding Celsius values. I could type this initially. You see what I'm doing here? Look at that. All cell references, but that is doing the slope, which is in cell B12, times x, which is in, or C, which is in cell B16, plus the intercept, which is in cell B13. And this will give the correct answer, 32. However, it does not give the correct answer if I continue downward. 64 degrees Fahrenheit is not the same as 2 degrees Celsius. So, how do I fix that? What's the problem? The problem is that the Excel's very feature of updating the cell references as you click and drag downward is hindering us here because these numbers are not staying the same as you go downward. So, and in fact, let me just show you something here quick. It would even perhaps result in an error if I go too far enough downward. Yeah, look at that. It doesn't know what to do there. That's because it's trying to plug in a letter into a formula. C is in cell B15, which is just a letter. It's text. So we don't want to do that. The dollar sign is within formulas is Excel's way of keeping cell references fixed. So I'm going to do that here real quick. I'm not going to have time to graph this, I think, in this video. If I put a dollar sign in front of the B, that's going to keep the column fixed. And then if I put a dollar sign in front of the 12, that's going to keep the row fixed at 12 when I'm referring to that number in cell B12 in this formula down here. When I copy and drag this down, that cell reference B12 will stay fixed because of the dollar sign. Now actually, it's probably just sufficient to have it just in front of the 12 to keep the row fixed. But initially here, to play it safe, put a dollar sign both in front of the B and in front of the 12, or if you prefer thinking of it as in front and behind the B. That'll keep the cell reference fixed at B12 as I copy and paste downward. I want to keep that slope fixed. I want it to be 1.8 all the time. I don't want to keep the X fixed, or excuse me, the C fixed, so I'm not going to put a dollar sign around the B in B16, but I do want to keep the cell reference for the intercept fixed at B13, and so notice that I put dollar signs in there too. $1 sign in front of the B, a dollar sign in front of the 13. So the slope and the intercept are going to stay fixed. That's the point here as I copy and paste this formula downward, but the C value, B16, is not going to stay fixed because I don't have dollar signs in there. 32, and now it does it correctly. For the other ones, 2 degrees Celsius is 35.6 degrees Fahrenheit. It went up by 3.6 units as C increased by 2. And if we go down to 100, oh, sometimes you go too far here. It's easy to go too far. Everything gets updated correctly. and notice that 100 degrees Celsius is 212 degrees Fahrenheit. So make sure you take some time to think about it, maybe rewatch it and rethink about it, experiment on your own, and we'll come back to this in the next video too.